All right, so this video is about dilating a line. All right, so before we get to the page that we talked about, I gave you guys homework. Understand this. This is a line y equals x. And basically the center of this line right here is at the origin. This is my center. It's not really the center of a line, but the center of this dilation is going to be used to be 0, 0. Let's say I chose this point. Let's say I chose a point 2, 2. If I had a scale factor of 2, that means I multiply that coordinate by 2. So if I had a scale factor of 2, 2, 2 becomes 4, 4. So that's right here. Notice that the point's still on the same line. 4, 4 is right there, and it's still on the same line. That goes for any other point in that line. If I chose any point on that line, and I multiply by a scale factor, it should appear on the same line. If I took 0, 0, I multiply it by 2, it becomes 0, 0, still on the line. If I took negative 3, negative 3, if I multiply by 2 for my scale factor, I get negative 6, 6, negative 6. So I get a point on that line. So basically, if you dilate a point on the line as it's centered at the origin, it didn't change. It just gives you more points on that line. That can keep going forever because this line goes on for infinity in both directions there. Every time you do that, it maps the line back onto itself. So basically, if a dilation maps a line passing through the center of the dilation onto itself. So in this case, the center was 0, 0. But even if the line would say here, that was my center of my dilation. If I had a new dilation, that was my center. If I gave you a line to pass through that point, any coordinate, any scale factor will give you more and more coordinates that lie on the exact same line. So when you have a dilation that passes through the center, any dilation of it, whether it's a scale factor of 1 or 0 or 2 or whatever else, maps that same line onto itself. All right, so I'm going to change it and give you a different line. All right, so I got a new one. So suppose we got a line that didn't pass through the center, and it's not even the origin anymore. I created a new center. I said this point was my center. And let's say my scale factor was 2. All right, so I like this point because I can kind of measure how far it is away from it. So I know this point is exactly 1 away from my center. If my scale factor is 2, my new point has to be 2 away from my center. So it has to be 2 away, so that's a new point there. So I got this 1 point on the line. Just like this is 1 away, the new point will have to be 1, 2 away. So it has to go through here. So these 2 points represent the line had it been not passing through the origin or passing through the center of it and had a scale factor of 2. So when you have a scale factor of any number and you don't pass through the origin, you get a line that's parallel to the original. So you got a parallel line to the original one. And what you ordinarily teach it is, if I want to come up with the coordinates on that line, I would choose those points and I would subtract the center away from it to come back here, multiply my scale factor, add center back to it. But just a visual representation is this. But again, we talked about before how we can actually graph it where we subtract the center back to the origin, multiply by a scale factor, and add the center back to it to come up with the points that would be here on this line. For example, instead of doing it all visual, kind of like the algebra at all, so we decided it would be, we'll subtract our center from each of those coordinates. So I'm subtract 3, my center is 3, 2, so I'm subtract 3, subtract 2 from each of my coordinates. Oh, let's back it up. First of all, I chose 2 points on that line. This is point 1, 1, and this is the point 2, 2. That's 1, 1. This is the point 2, 2. So I just chose 2 points on that line, and I want to dilate them with that scale factor and that center. So 1, 1 is here and 2, 2 is there. If I subtract my center from it, you come up with a coordinate that is negative 2, negative 1, and negative 1, 0. You have your scale factor, which is 2. So multiply all those numbers by 2, give you negative 4, negative 2, negative 2, 0. And after you have the scale factor of 2, you add back the center. So you can add back, the center was 3, 2. So you can add 3, add 2, add 3, and add 2. So you're going to come up with coordinates that would be -1, 0, and a coordinate that would be, looks to be +1, 2. You add those together. So if I check it out, -1, 0 should be a point on that line. Let's check. -1, 0 is here. Other point was +1, 2. So it means I should check that point out. So +1, 2 would be here. And I got 2 points to make a line with, and it works. And that's what it is. So anyway, so the activity you guys did was this. Here's the activity. And in the activity, with the GeoGebra lesson, they actually kind of play with the pictures. It says fill in the blanks. First of all, a dilation maps a line not passing through the center of the dilation to another line that is parallel to the original line. Also, a dilation maps a line passing through the center of the dilation onto itself. That's what we talked about first, when we first looked at them. And if I kept graphing points, I kept just expanding the line, come up with new points on the same line. So if you actually pass through the center and you dilate the points, you come up with more points that just exist on the same line, just further apart from the center, or closer and closer to the center, if the number is smaller than 1. So it says match the dilation with the correct scale factor, the dashed line. So we looked at this. This line looks to be getting closer to the original line. So we looked at this one. This actually, it looks like the original line, and it's slightly further away from it. So that looks to be, if you play with the numbers on the Geogebra page, you should have found that this one was letter C. And the one here, you should have found that this is like almost 3 times away from it. So you should have found this one was represented by the letter A. And the one beneath, if you play with the scale factor for it, you should have found this one was represented by the letter D. And here, you saw the same line mapped onto itself, pretty much. So you should have found that K value was 1. So actually, that K value was represented by the letter B, which made it 1. K value was 1. All right, flipping to the back. All right, on the back it says, if you dilate a line about point A with a scale factor of 6, what will it look like? So because this line passed through point A with the center, if that's my center and I pass through that point, if I dilate that point, it's just going to be 6 further away, like it's going to be out there. If I dilate that point, it's going to be someplace out there. So it's still going to lie on the line. So the question says, what would it look like? It would look like the same line. Because if you just get more points on the same line, you still have the same line. Number 4 says, line M has been dilated by a scale factor of 0.5 and the center at A. So it says the image is the same line as the pre-image. Is the result different from the result in example 3? And the answer is no. Example 3 is the exact same line as pre-image 2. So even though you have a scale factor that is different, you still have the same line. And it doesn't give you a different looking picture. You just got more points on that line in different places. The points might be closer together, like the point might be here, and that might be there. But then change the fact that it represents the exact same line. You just have points in different places. But anyway, so that's it, and that's how we dilate lines. That's all I have. Good luck.